everyone, welcome back. My name's Rob, and this is a class on introductory statistics for the psychological sciences. And this is the second part of a two-part lecture. The first part was on how to conduct correlated groups t-tests, and the second part is on how to report confidence intervals. So in this part, we're going to go over what a confidence interval is, why they're important to report, how to compute them, and how to report them in APA style. So as always, over here are the PowerPoint slides, and up here is our virtual whiteboard. If you find this video helpful, please don't forget to like and subscribe and hit the notification bell to receive future updates on videos just like this one. So let's just dive in here on confidence intervals. So what is a confidence interval? Well, a confidence interval is a range of values that probably contains the population value. So if you remember, we're in the business when we're conducting inferential statistics of making an inference about a population from a sample that we've collected. And when we do that, our mean value of our sample is an unbiased estimate of our population mean. However, the standard deviation of our sample is a biased estimate of our standard deviation of the population. So basically, our best guess when trying to predict a population mean is the sample mean. However, it doesn't mean when we say that the sample mean is an unbiased estimate of the population mean, it doesn't mean that our sample mean is going to be correct all the time. It means that there's an equal probability that it will underestimate the population mean and an equal probability that it will overestimate the population mean. And therefore, we want to put bounds around what the range of possible values that a population could take on given a particular sample mean. So essentially, a confidence interval estimates a region within which a population mean is likely to be found. And so we use the sample mean to do this. We're going to say that our sample mean is the best guess of a population mean. However, we could be off. We could underestimate the population mean. We could overestimate the population mean. So we want a range that we are confident in that the population mean will actually fall given a particular sample mean. And so that is a confidence interval. And a confidence interval is a range of values that probably contains the population mean. The limits of that confidence interval, there's a lower bound and an upper bound, are the values that are the kind of the cutoffs, right? And so typically we're going to, in APA style, we like to report 95% confidence intervals in general. And what that would mean is that 95% of the time, given a particular sample mean, the population mean will fall between some lower bound and some upper bound. Okay, so here we see a normal distribution, and at the lower end, we see this area that's not shaded red, and at the upper end, an area that's not shaded red. This is very similar to when we would draw the line in the sand and compute our t-critical value. What we were doing there is we wanted to find the region that cut off 0.025% in the lower tail and in the upper tail. Here, we're doing a very similar thing, but what we're interested in is this entire red shaded region. And this red shaded region represents all of the possible values that a particular population mean could take given a particular sample mean. Put another way, 95% of the time, a population mean will fall within this range given a particular sample mean. So let's look at what the, so this 95% confidence interval is simply an interval that the population mean could take given a particular sample mean. And we report it by saying in the middle, what our value was, and then what the lower bound is and what the upper bound is. So we can see here 95% of the scores are going to occur within the non-shaded region on this picture. So let's just do the compute a confidence interval for the example that we had used in the prior lecture. So I'll spare you reading this. You can pause and read it yourself, or go back and look at the first part of this lecture where we completely did the correlated groups t-test on this example. Okay, so we want to compute a 95% confidence interval around our statistic. So we can see here that we want to report the lower bound of 0.025%. And then in the middle, we report essentially our t-statistic, and then the upper bound of that value. So let's figure out how to compute this. So the first thing we should do is go back to what we had done on our whiteboard for this t-test. And we can see the first thing that we need in this equation for the lower bound is x obtained. In other words, our sample mean. And that is the numerator of our t equation. So we can highlight that on here. The second thing we need, we're going to take our sample mean, our x bar, and we're going to subtract the standard error times the critical value of t. So our standard error is simply our denominator, and the critical value of t is up here, was plus or minus 2.093. Okay, so let's go ahead and compute the upper and lower bounds. So, mu of lower is going to be equal to 55.3 minus 13.1539 and our mu of upper is going to be 55.3 plus 13.1539. And again, this value is simply our standard error times our t critical value. Okay, so with this, our mu of lower is going to be equal to 42.15, and our mu of upper is going to be equal to 68.45. Okay, so those are the upper and lower bounds of our 95% confidence interval. Now, one key thing about confidence intervals is the wider they are, as you can imagine, the less confidence that we have in the precision of our mean estimate. But if a confidence interval is narrow and tightly fits around our sample mean, that means we have greater confidence in our estimate of the population mean. So how do we write this up? Well, let's go to our APA style write-up. So what did you do is going to be exactly the same. But when we get to what did you find, right? Everything else is exactly the same in the write-up. Now we just insert, after we report our p-value, we insert a 95% confidence interval, and then bracket the lower bound, comma, the upper bound. And so what does it mean? Same thing. Reporting this 95% confidence confidence interval gives the reader a sense of how much this sample mean might vary given the amount of error in our estimate of the population mean. So it's really good if this was much more narrow. And one way we can do that, the way we can reduce our error, is by increasing our sample size, for example, or by evaluating effects that are larger rather than smaller effects. Okay. And so here is the full write-up, including the 95% confidence interval. So I hope this was informative to you, and please let me know if you have any questions. Leave comments in the comment sections below if you do, and thank you.